Welcome to the first lecture on thermodynamics and statistical physics. So first we will start with the thermodynamics portion, and in this lecture we will first take a basic overview of the subject and then we will learn about the laws of thermodynamics. So let's start. First of all, what is thermodynamics? What are we going to study in thermodynamics? So remember, thermodynamics is a macroscopic science. So what does that mean? So to describe any system, we have two types of descriptions. One is the macroscopic description, another is the microscopic description. The microscopic description or the statistical approach is the study of system at the atomic level with the help of microscopic parameters such as mass, velocity, momentum, etc. These parameters cannot be directly measured in the laboratory or cannot be perceived by our senses. Whereas in macroscopic description or the thermodynamic approach, what we do is that instead of studying the constituent particles, we study the system as a bulk with the help of macroscopic parameters such as pressure, volume, temperature, and these parameters can be directly measured in the laboratory and also can be perceived by our senses. So next, in thermodynamics, we study about heat, temperature, and interconversion of heat with other forms of energy. So now, what is the temperature? What is the difference between heat and temperature? So we know that heat is a form of energy that flows from a hot body to a cold body, whereas temperature is the degree of hotness or coldness. Say for example, we have ice in a beaker and we have boiling water in another beaker. If we put our fingers and touch the ice, we can feel that it is cold. Similarly, if we put our fingers into the boiling water, we can feel that it is hot. We may even burn our fingers. And say we have lukewarm water in a beaker. If we touch that, we can say that yes, it is slightly warm. But we need a definite physical parameter to measure the exact degree of hotness or coldness. So that physical parameter is temperature, and its SI unit is Kelvin, whereas the SI unit of heat is Joule, since it is a form of energy. Next, the word thermodynamics can be dissected into two words, thermo and dynamics, where thermo is related to heat and dynamics is related to mechanics. So basically, the meaning of thermodynamics from here comes out to be mechanics of heat. That is, we will supply heat to a substance and there will be some changes in the substance and we will study all these changes in thermodynamics. So thermodynamics is also a type of mechanics, but what is the difference between thermodynamics and mechanics? Say, for example, we have a gun and we fire a bullet. So the kinetic energy of bullet will change, right? And the motion of the whole body is changing. So this study of this motion is involved in mechanics. Whereas, let's say now this bullet strikes a wooden block. So what will happen? As it strikes the wooden block, all of its kinetic energy will get converted into heat, and the temperature of the bullet as well as the outer layers of the wood will increase. So what is happening? The internal motion is changing. So the study of this internal disordered motion is involved in thermodynamics. In thermodynamics, we are not concerned about the motion of the complete body. We are only concerned with the internal motions. But in mechanics, we will study the motion of the whole body. Okay. So now let's say we have a substance and we supply heat. So two types of changes may occur. First, there may be rise in temperature, which is related to specific heat. And or else there can be change in phase, which is related to latent heat. Now the change in phase can be from solid to liquid, liquid to gas, gas to solid, and vice versa. For example, from solid to liquid, phase change is called melting. For example, ice melts into water. Liquid to gas phase change is called vaporization. For example, water vaporizes to form steam. Next, gas to solid phase change is called deposition. For example, in thin film deposition, we deposit layers of different vapors on a substrate. Similarly, the change in phase from solid to gas is called sublimation. For example, if we keep naphthalene balls for a few days in the open, then its size decreases. So what is happening? It is directly changing from solid phase to gaseous phase, right? Next, the phase change from gas to liquid is called condensation. For example, you must have observed in winters, there is condensation on glass surfaces. Next, the phase change from liquid to solid is called freezing. For example, we freeze water to form ice. Okay, so these are the various types of phase changes. So next, what is specific heat? So you must have observed that when we heat any substance, its temperature is increasing. That is, when we apply heat externally, its temperature increases. Whereas if we extract heat from a substance, its temperature decreases. So from this, we can say that change in heat is directly proportional to change in temperature. Also, if we have a small amount of mass, then to increase the temperature by say 1 degree Celsius, we will require a small amount of heat. Whereas if we have a larger amount of substance, the same substance, and we have to again increase the temperature by 1 degree Celsius, we will require a larger amount of heat. So from this, we can say that the change in heat is also directly proportional to mass. So from here, we can say that change in heat is directly proportional to mass and change in temperature. Or from here, we can say that change in heat is equal to ms delta T, where S is the proportionality constant and it is called the specific heat. So from this expression, we can derive the expression for specific heat as 1 by m times of dq by dt, and its SI unit will be joule per kg per Kelvin. Next, we can define specific heat from this expression as the amount of heat required to increase the temperature of unit mass of substance by 1 degree Celsius or 1 Kelvin is called the specific heat. Similarly, if we have to increase the temperature of a substance which is given in moles, then the amount of heat required to increase 1 the temperature of 1 mole of substance by 1 degree Celsius or 1 Kelvin is known as the molar specific heat, and we denote it by C. Its SI unit will be joule per mole per Kelvin. And for gases, we define two types of specific heat. One is the specific heat at constant volume, which is denoted by Cv, and it is given by dq by dt at constant volume. Another is specific heat at constant pressure, whose expression is given by Cp is equal to dq by dt at constant pressure. Next, the latent heat. Say, suppose we are having some system, ideal system, and we are applying some heat. Let's say we are boiling water, which is initially at say 30 degrees Celsius, and we also put a thermometer to measure the change in temperature. So what we will observe, the reading in the thermometer will increase up to 100 degrees Celsius, and after that, even if we keep on applying heat, the temperature won't rise further. So where is this heat going? This heat is used in changing the phase of the substance. So water will change into steam. So this is known as latent heat, and it means hidden heat, because we cannot measure it with the help of thermometer. It is not showing in the thermometer, so it is not also called as hidden heat, and its expression is given by Q is equal to ml, where L is the latent heat, Q is the amount of heat given, and m is the mass of the substance. SI unit is joule per kg. So from here, the expression of latent heat will be Q by m, and we can define it as the amount of heat required to change the phase of unit mass of substance. Okay, so there will be two types of latent heat. One is the latent heat of fusion or latent heat of melting, and there is the latent heat of vaporization or latent heat of boiling. So if we have to change the phase from solid to liquid, then the amount of heat required to change the state of unit mass of the substance from solid to liquid is at its melting point is known as latent heat of fusion, and the amount of heat required to change the phase of unit mass of substance from liquid to gas is at its boiling point is called the latent heat of vaporization or latent heat of